J-PARSE is a method for the velocity control of serial manipulators near and away from singularities. It proposes a modified computation of the first-order inverse kinematics when the Jacobian matrix becomes ill-conditioned. J-PARSE guarantees stable control to reachable poses even in the presence of singularities. It is benchmarked in a variety of settings for moving into and out of singular poses. It is also demonstrated for other applications of online Velocity-IK control and is a freely available resource. When the robot is close to singularity, the specified end effector velocity is projected onto the singular and non-singular directions. The singular component is scaled down to obtain a modified velocity command in the task space. To compute joint speeds, a safety Jacobian matrix is constructed by ensuring that the aspect ratio of the manipulability ellipsoid remains above a selected minimum. The safety Jacobian matrix is then inverted to compute the desired speeds in the joint space. A similar approach helps the manipulator to exit singular regions. We compare the resulting behavior with the regular pseudo-inverse, which involves the inversion of a singular matrix, leading to unstable behavior in singular neighborhoods. Next, we test damp least squares inversion, which is free of numerical instabilities but causes steady-state errors even at non-singular poses and does not approach the boundary of the workspace. By comparison, J-PARSE reaches both non-singular and singular poses, allowing the manipulator to reach as close to the goal as possible, with the measure of manipulability dropping to 0. When requested to return to non-singular regions, the manipulator is able to slowly and safely exit the singularity at a speed dictated by tunable gains. In teleoperation, commercially available manipulators often default to an emergency stop when brought close to singularity. In contrast, J-PARSE allows the operator to guide the arm to the full extent of its reachable workspace and back. In this example, the U-factory X-arm is being driven by a human teleoperator who controls the position and orientation of the gripper using a space mouse. The ability to reach the cup and move it elsewhere depends upon the smooth handling of singular regions, not by avoiding them, but by stably approaching and retreating from them. By modifying the end effector motion in accordance with the manipulability at any given pose, J-PARSE ensures that the manipulator performs to its full capability in the feasible directions. In the directions where mobility is lost, motion is requested only to the extent feasible. Given enough time and the appropriate parameters, the manipulator is able to achieve any goal within its reachable workspace. Aside from freeing the teleoperator from having to account for singularities, this makes it possible to collect a wider range of demonstrations for training autonomous policies in the task space. Here, a vision-based policy trained with such demonstrations is able to pick the cup up from the edge of the workspace and move it to the marked square. In another example, the Kinova Gen 3 manipulator arm uses its camera to follow a visual fiducial moving around inside and outside the workspace. The robot reaches its fully extended pose a number of times and is able to retreat from it smoothly whenever required. J-PARSE can be incorporated into existing paradigms for Velocity-IK control. It is hoped that it will enable users of collaborative, assistive, and teleoperated arms to intuitively and freely control the end effector in the task space.